multiplying monomials and laws of exponents. Today we're going to talk about this in our session today. What is a monomial? Monomial is a number, a variable, or a product of numbers and variables with whole number exponents. As you can see, those are examples of monomials with the number and the variables attached to it. Notice there are some numbers and variables that don't have written the exponent on top. We'll talk about that in a minute. As you can see, we have our exponent and our base. This contains a monomial, and you look at the examples. How do I identify which one is the base and which one is the exponent? As you can see, these are examples of how to find the base and then the exponent. If you notice, for the first one, c is the base, 5 is the exponent. For the second one, 4v squared. 4 and v are the bases, 1 and 2 are the exponents. Yes, 4 has the exponent of 1 because there's 1 there. 2, you guessed it, again, 2 to the first power. It's 1 and 6 are the exponents, and 2 and a are the bases. Now, h is the base, and 1 is the exponent for the last one. Multiplication, product of powers. When the bases are the same, keep the base and add the exponents. As you can see, the bases are the same, so therefore, when you see this, you're going to go ahead and just add the exponents. Examples. As you can see here, 5 to 8b to the 5th power times b to the 3rd, or b cubed. If I go ahead and add those together, that's simply just b to the 8th. Next one, g, their bases are the same. 7 plus 2 gives me 9, so it's g to the 9th power. Notice this is written. This is still multiplication, whether you see parentheses or the dot. I've simply, because the bases are the same, add those two together, and I get f is equal to the 11th power. Then last, notice my monomials, my numbers aren't the same, but my variable bases are. So therefore, you're just simply going to multiply those two numbers and leave a the same, and simply do what you did earlier because this multiplication sign. So therefore, your final answer is 15a to the 10th power. Let's try it. Is this a true statement? Thumbs up, thumbs down, or thumbs to the side? Yes, it is a true statement. Power of a power. Let's say that the bases stay the same and the exponents are multiplied. If you look here, now there's difference. Alright? N doesn't have a base. So when you see this form, you simply just multiply those two exponents together. Here's your examples. Now, I'm going to talk about this last one. It has two sets of parentheses, but notice the only base there is t. You still have to multiply these across. So therefore, 2 times 4 times 3 is equal to 24. Let's try it. Is this a true statement? Thumbs up again, thumbs to the side, or thumbs down. If you have your thumbs up, that is a true statement. Now, the power of a product. The exponent applies to all the numbers and variables inside the parentheses. If you notice, I have 2 variables that are my bases. If I go ahead and look at this exponent of n and I multiply it, there is no base attached to it, so you simply just do one thing. That word starts with a D. What is that word? You guessed it, distribute. You're going to distribute the power to both bases. So therefore, here are some examples. Now, if you notice on this example, 6 is raised to cubed power. Yes, 6 cubed. You can say 6 to the third, or in mathematical terms, 6 cubed. So therefore, 6 cubed is 216. And you leave all these A, B, C, and D. They're all raised to the cubed power as well, individually. Let's try it. Is this a true statement? Yes, our bases are different, so therefore we're going to distribute this 3 to both of these bases, and this is a true statement. Now, a power of a product continuation. Using what you've learned about exponents, try to simplify the following expression. Aha, a little tricky, huh? It's nothing that hard. All you have to do is do what? That word again starts with a D. That's right. I'm going to distribute this power, that is exponent P, to both M and N, since their bases are different. Now, here's some examples. Notice that all of them are doing the same thing. We're distributing the power that's outside the parentheses to each and every number or base that is within the problem. Let's see and try this. Is this a true statement? Thumbs up, thumbs down, or thumbs to the side? If you have your thumbs up, this is correct. The next video that we're going to talk about division. That is going to be saved for the next day. You have some problems to do. I'll let your teacher explain. This is Coach Ford signing out.